Okay, good evening. Today's topic is ethics of artificial intelligence, an emerging topic in AI and of relevance to machine learning. Okay, the topics we'll cover will first take up the case of large language models. These are language models that can generate text. The generative models of text, which use the kinds of sequential models we have briefly touched upon. And that's the first topic, case of large language models. Then we will discuss performance versus trust in artificial intelligence. And then we'll take up two definitions of ethics, right? These are all human things, human qualities. And why does it matter if you're going to be doing machine learning? And then kinds of biases that machine learning programs can have and the sources of bias and so on. Okay, so these are the topics for today. So let's begin by discussing some language generation models. Okay, if you recall, generative models are models that digest lots and lots of input samples, examples, and create models from which we can generate samples, right? That's what generative models do. More generally, generative models can be used to represent the probability distributions. So if we have language represented in some, word to vector form, so we're talking about vectors, and these vectors one can learn the probability distribution. And once you have a model of the examples, you can systematically generate samples from them, conditional distributions based on what you have seen and so on. As opposed to discriminative models are the supervised learning models, which learn how to discriminate between classes. Generative models just learn the probability distributions. Generative models can also be used if you are able to generate distributions to be able to do discrimination also. But here we're talking about generative models. In natural language processing, a language model, abbreviated as LM, called GPT-2. This was developed by the Allen Institute for Artificial Intelligence. Uh, they input an enormous quantity of text so that they can predict. So here is an example: GPT-2 trained to predict next word in a 40 gigabyte of internet text. All right, so they accumulated a lot of text, and their job was to do a prediction. This is just like you have a sequence one after the other. What is the next word, like a hidden Markov model type of thing, except this is a different kind of generative model, use transformers and so on. And the sentence is, the cat sat on the, and we are asking the GPT-2 to predict what is the next word. And it ran through all the kind of text it had previously seen, and based on these probabilities, it said floor with 8.4% probability, bed with 7.3% probability, couch, ground, table, sofa, edge, chair, desk, window. All right. So these are the kinds of words it came up with. So it says I can predict the next word with these probabilities. Of course, we might say, let's use the maximum a posteriori probability answer, which would say the most probable value is floor. So we say that is the output of the GPT-2 is the cat sat on the floor, right? Well, now what if I fed into this GPT-2 a couple of sentences and ask it to keep generating, further text. So you can do that. It can generate an arbitrary, volume of text coming out of it. So GPT-2 generated synthetic text for a system prompt, human written. So, you typed in a shocking finding, scientists discovered a herd of unicorns living in a remote, previously unexplored valley in the Andes Mountains. Even more surprising to the researchers was the fact that the unicorns spoke perfect English. All right. So somebody typed into this GPT-2 something which is kind of fanciful, that these unicorns are like horses with horns on their head. And they found in the Andes Mountains unicorns that spoke perfect English. Anyway, so what did GPT to do? So it no, it did model completion. It says, okay, if that's the input, I'm going to generate new sentences, not just word, sentences now. The scientists named the population after the distinctive horn Ovid's unicorn. This is all made up stuff. These four-horned silver white unicorns were previously unknown to science. Now, after almost 2 centuries, the mystery of what sparked this odd phenomenon is finally solved. Wow, it's able to write like that. Dr. Jorge Perez, an evolutionary biologist from the University of La Paz, and several companions were exploring the Andes Mountains when they found a small valley with no other animals or humans. Perez noticed that the valley had what appeared to be a natural fountain surrounded by two peaks of rock and silver snow. Right? It's made up all this stuff, made the name up, Jorge Perez. Perez and the others then ventured further into the valley. By the time we reached, it's even giving a quote, by the time we reached the top of one peak, the water looked blue with some crystals on top, said Perez. Perez and his friends were astonished to see the unicorn herd. These creatures could be seen from the air without having to move too much to see them. They were so close they could touch their horns. All right. So there is a whole story generated by GPT-2 and is able to do it. It's all based on machine learning. It is based on deep learning, and it is based on a model known as transformer model, which is able to keep the context in mind as it's generating new words. And it all makes perfect sense. It's all legal English and all that. Okay, so there's the example. So we then move on to the kind of risks. So this lecture is about ethics of AI. So there has been a huge discussion going on now about ethics of AI and what are the risks of such language models that can generate these types of text. All right. So about a month ago, this paper is being circulated on the internet. The title of the paper is On the Dangers of Stochastic Parrots. Can language models be too big? So all of this was generated something like a parrot saying something. They called it as a stochastic parrot in the sense we use stochastic gradient descent and stochastic methods here. They said, let's call it a stochastic parrot. It's able to generate words like a parrot. And the paper was written by a group at Google called Gebru, Bender, and so on. And just 2 days ago, it was summarized in MIT's Technology Review and so on. The reason this is getting a lot of attention is that the first author of the paper, Gebru, was fired by Google because of some of the controversial things this particular paper had to say. And it's interesting to then to look at what is it that the paper said, and does it relate to reality in any way? So I looked at that paper, and I summarized it as containing 4 major points about risks of language models. They're talking about ethics of AI here. First one is something that is kind of the usual arguments you hear about the environment, right? Environmental and financial costs. And let me, I guess I forgot now to put this as a slideshow. Okay, there it is, slideshow. Hopefully it's more readable now. All right, now, uh, so environmental financial costs, common carbon footprint benchmarks in pounds of CO2 equivalent. Like the round trip flight between New York and San Francisco for one passenger is 1,984 pounds of CO2. Human life, average 1 year. So when we live for 1 year, the carbon footprint is 11,000 pounds of carbon dioxide. I suppose that's how much we each human being emits to the world. And American life, average 1 year, an American person emits 36,000 pounds of carbon dioxide to the atmosphere. US car, including fuel, average uh, one lifetime of one car is 125,000 pounds of carbon dioxide, I suppose, all the emissions from the car. And transformer, this is this is a deep learning AI model, a transformer with 213 million parameters. We've been talking about parametric space. We're talking about, well, what's between friends? 213 million parameters. Why not, right? Not hundreds, thousands, but millions of parameters. With neural architecture search, yeah, with that many parameters, and you're searching for different models, how many layers, and all that. And that, they say, is 626,155 pounds of CO2. And you see how much bigger that is. So they need to keep these GPUs running for a while in order to figure out all these parameters, right? Which is why we need stochastic gradient descent to save the world. Well, okay, that's possible. And the estimated costs of training a model is the table on the right side. So what is the cost of training this model? Transformer with 65 million parameters is energy consumption 27 kilowatts per hour. Carbon footprint we already saw is 41 to $140 cloud compute cost. If it is 213 million parameters, that goes up to 289 to $981. Elmo, a particular model which has many more parameters, $433, 433 to 100,472. BERT is quite a famous one, I think came from Google. That one was 3,751 to 12,571 cloud compute cost. Transformer with 213 million parameters with neural network architecture search. Wow, look at that price. It went up to 1 million to $3 million. And GPT-2, the program we just saw, whose output we just saw, that one wasn't as bad as this transformer model, which is $12,900 to $43,000. So they're saying that even in training these models, we are using up considerable amounts of resources. And so let's see. Okay, that's the first point. The second point is LM stands for language model. Language models trained on exponentially increasing amounts of text. So the amount of text that's going into these machines to learn these models is exponentially increasing. They're going from 100 to 1,000 to 10,000 to 100,000 and so on. And researchers collect all the data they can from the internet. So what happens is when you're collecting all this language from the internet, you are bringing in some bad stuff, racist, sexist, and otherwise abusive language ends up in the training data. The internet has all of this kind of stuff. So it's all going into the program, and so it has its consequences. And the third point here is there is some misdirected research here that language models don't understand language and are merely excellent at manipulating it. So, is it really understanding when it's talking about, we saw that example of the unicorns. It is generating all of this text. It almost sounds meaningful. It's as if it understood what you're talking about. It's generating all of this. It's manipulating text. And some of the concern that these people who wrote the paper was that big tech can make money from models. That when you are able to generate these kinds of text and so on, one can write a book like this, right? So you can make money from these models. So they're saying the research effort is misdirected. Those people who are all sitting and generating more and more of these kinds of texts and so on are not doing proper research at Google or whatever. And then the final point is illusions of meaning. And it is easy to use language models to fool people, right? So we were just happily reading that story. And it is easy to use language models to fool people. Students once there's an example is given here. A student churned out AI generated self-help. Is that what it's saying there? Yeah, self-help and productivity advice on a blog, which went viral. So a student was able to type in some text and which generated some self-help and productivity advice, how people should work and all these kinds of things. And people really liked what it had to say. It was all generated by one of these programs. So this has been making the news all over, right? The last week or so, that Gebru was fired by Google. There's got to be more to it than this paper itself. Some of it might be that they're saying Google is doing this and Google didn't like it. That is not what they're doing. Their research is not about, making money off of fooling people and all that, right? Yeah. Okay, so let's move on now. So we just saw that it is possible and that to generate a language that has a cost on human beings, right? So now let's talk about trust in AI. Uh, so now, if an AI generates it behaves as good as human beings, like recognizing cats and dogs is one thing, or learning how to play, Atari, or so on, right? So it's human-like. So then we ask the question: is human-like good enough? What happens to trust in a world where machines generate human-like output and make human-like decisions, right? So, so do you trust these things when these are generated, right? So here are specific examples of scenarios where you're asking, will you trust the AI? Can I trust an autonomous vehicle to have seen me, right? Here is a car that is going along on its own, and can I trust it? Can I trust the algorithm processing my house loan to be fair? So you have submitted an application to buy a house, and is it going to be a fair program that is not going to discriminate against you somehow? And then another question, can we trust the AI in the emergency room enough to make life and death decisions for us, right? It's an AI running in a hospital, and will you trust? So the question now is, AI is human-like, all right, but will you trust it? I mean, previously we saw some stories being generated. Okay, those might be harmless. Here we are putting it in a situation where we are trusting, will you trust it? So this is a cartoon I found somewhere which says role of data in AI. And the person on the left is saying, this is your machine learning system. Machine learning system is this pile here. This whole pile of dirt is the machine learning system. And this guy is asking, this is your machine learning system? And the guy who's building this machine learning is answering, yep, you pour the data into this big pile of linear algebra, then collect the answers on the other side, right? So look at this, data is going in through this, and look at this, there is a matrix here. This must be a covariance matrix here, or a Hessian matrix or something. And look at all these x naught, x1, all arranged like a matrix. There's a lambda, there is a mu, and there's an f, and all the usual symbols. And he's just and you put in data, and it's giving answers to whatever questions you can ask. And this guy is asking, what if the answers are wrong? Just stir the pile until they start looking right. Says, all right, mix up all your data some more, and maybe multiply by some more matrices, and that's going to be your machine learning, right? So role of data. So anyway, the main point of this is that the machine learning system, what it generates is based on what kind of data you're feeding it into this system. Okay, then let's then talk about what do we mean by ethics. So we talked about trust. I guess trust has some implication to whether the program behaves ethically. And so let's begin with ethics and then come back to a machine learning program. Ethics or moral philosophy is a branch of philosophy. Okay, ethics itself is a branch of philosophy. It involves systematizing, defending, and recommending concepts of right and wrong, right? So, so it involves. So this is a Wikipedia definition. What is the definition of ethics? Systematizing, defending, and recommending concepts. So what is right? What is wrong? So ethics tells us what is right, what is wrong. Ethics seeks to resolve questions of human morality, right? This is the general definition: good and evil, right and wrong, virtue and vice, justice and crime, all of these things, right? Ethics really seeks to resolve. So one of it is a branch of philosophy, and where we are somehow recommending concepts of right and wrong. And the other one, ethics seems more specific to a particular questions of human morality, saying which is right, which is wrong, right? That kind of a thing. So ethics covers all of these kinds of ideas. Okay, so those two ideas leads us to two definitions of ethics. So one is that ethics are moral principles governing actions of an individual. Right. Bear with me while we are talking about philosophy right now, because this kind of comes back into methods of AI. The rules or decision paths that help determine what is good or what is right, right? So ethics of tech. In technology, we have set of rules or decision paths used to determine its behavior. So we have a program that makes follow some paths to determine behavior, typically captured in some design document as a sequence diagram or user story. All right. So we have some design document. The team is building a software for something, and they have decided what path to take. They captured in a design document, saying, what do we do in this situation? Maybe in a hospital scenario, we are designing a machine learning system to monitor a patient and so on. But how does a team determine a good or right outcome, and for whom? Is it universally good or only for some? Is it good under certain contexts and not in others? Is it good against some yardsticks but not so good for others? All right. So, how does the team determine a good or right outcome? All right. So that's one question. What are the moral principles governing actions of an individual or a program? Is it based on a general population, or is it for a specific individual, and so on? All right, the second point about ethics is dealing with right versus wrong and moral obligations and duties of humans. All right. So the first one was a design document for a program, and here is the ethical quality of its prediction or the end outcomes drawn out of that, and the impact it has on humans. Take for example the bank loan, right? So the ethical quality of the prediction, what did it take into account, and what kind of impact it has if say a person wants to buy a house and it rejects based on various biases that the program might have built into it. How right, how fair, how just is the outcome and impact, and how well does it identify and declare the context it is right, fair, and just, as well as the context in which it is not. Can it control how and where it is used? All right. And what are the implications of losing control of this context? Being answerable to these constitute moral obligations and duties of developers of AI. All right. So this is saying that there is some level of thought has to be put into it in terms of what is the right thing to do. Of course, if it's a machine learning program, it is learning on its own. You can say it's just the data. But if there are any other logic that is being programmed, that is a fairness issue in the coding. Okay, now let's talk about why does it matter? Why does this matter? Ethics of AI. Given dizzying pace of AI mainstreaming, because AI is now being used for everything, accessible compute power, although we just saw it takes enormous amount of computing to figure out 213 million parameters, still, computing power is more and more and more and more accessible. Open source machine learning libraries, all this GPT-2 and programs like that are all now being made available to everybody. And this change is going to be rapid and at scale. So this is going to be something people to be aware of. All right, so we now go into some more specifics, harms that AI can cause. So a harm is caused when a prediction or end outcome negatively impacts an individual's ability to establish their rightful personhood, harms of representation, leading to or independently impacting their ability to access resources, harms of allocation. So, can a person establish their individual identity properly? That's a harm of representation. And whether they will get the appropriate resources that they're entitled to. So, the first part, personhood, is their identity. Incorrectly representing or failing to represent an individual's identity in a machine learning system is a harm, right? So if it takes into account, race and gender in making a decision, their identity is being used in a negative way. Any decision made by this system thereafter in regard to that individual is a harm as well. So this is not true, not just of AI, but it is true of any program that one might write that is not based on machine learning. So, landscape of ethics issues. So, applying ethical considerations to our individual situations is natural. Um, we are quick to spot instances when we were unfairly treated, for example, right? So, we are always making these judgments saying, all right, I was not treated fairly. All right, you're making a judgment about the ethical considerations with somebody dealing with you. But applying this for others, in larger, more complex contexts, when we are two steps removed from them, is extremely hard. So this is saying, while we are quick to spot bias when it's applied to us, will you be able to spot bias when it is applied to others who are not immediate, but two steps removed? Humans don't realize how biased they are until AI reproduces the same bias. Isn't that interesting? This is saying you are developing a system which might be extremely biased, and people don't realize that because it's a situation where they're removed from it. So, summary of ethics issues: what AI is, uh, what AI does, what AI impacts, and what AI can be. So we'll look at each of these separately. What AI is: bias and fairness. So the AI system biased or and it's fair. Accountability and remediability. That is it? Can it account itself? Can it tell you why it made the decision, and can it be fixed? Transparency, interpretability, and explainability. This is all about what AI is. So, what is this AI model that we have? The second one is what AI does in terms of safety, in terms of human AI interaction, in terms of cybersecurity and malicious use, in terms of privacy, control, and agency or lack thereof, right? So does AI is performing, and does it have enough protections built into it for safety, cybersecurity, and things like that? So that is what it does, is the second point. Third one is what AI impacts. This is when you deploy AI, automation, job loss, labor trends. That, of course, is one of the considerations is should we be developing AI to drive trucks and deprive so many people of their livelihood, right? Job loss, labor trends, impact to democracy and civil rights. Wow, AI impacts democracy. I don't know about voting, but when AI is used, does it have an impact on that? Human interaction, all right, that is a general issue today, whether AI is having an impact on even human interactions, right? Maybe with malicious things generated and so on. What AI can be is threats from human-like cognitive abilities. This is a little bit further down the line. It has got the ability of a human-like cognitive ability, concerns about singularity, control going up. Singularity is about machines becoming smarter than human beings in everything. Control going up to debates around robot rights to human rights and things like that. Those are all issues that could come up, in the future. So there are these issues of what embodied in AI, and what AI uh, is doing in performance, and what are its impacts on society, and what may be future impact. So these are summary of ethics issues here. So a little bit more detail on each of these. What AI is. A machine learning system consisting of a learner that, given a set of inputs, is able to learn something and use that learning to infer something else. All right. Enables man-machine interaction at different levels. Autonomous robots, that is, robots that operate without requiring real-time or frequent instruction from humans. Example, automobiles, drones, vacuum cleaners, so on, impact and change our operating environment, right? So AI enables man-machine interaction at different levels, and it indirectly, they change our behavior, right? So, so what AI is about what it is today, and what are its effects on us. Second one is what AI impacts. Technology products often trigger second and third order consequences that are not always obvious at first. And lines between real person and automated bot start to blur online as humans are bombarded with information, often fake at scales. The very notion of trust and therefore safety is shaken. All right, so the technology products have other consequences, not obvious at first. So there are blurring between real person and automated bots. And then the third point was ethics of what AI is. Commonly deployed AI is a set of math functions. Well, this course was largely about math, right? Math functions. We call it model. We talked about model for, discriminative model or the generative model and so on. That given some inputs, data learns something and use that to infer something else, make predictions. And ethical exploration of this realm covers issues like bias in a model's predictions and fairness or lack thereof of the outcomes, as well as approaches to address them via accountability and transparency, right? So this is so the ethics of what AI is issues of is there a bias in the model's predictions? Is there fairness in the outcomes? And so is there accountability, transparency? We saw this already. So we talked about cognitive bias. It's kind of interesting. This slide comes out of a psychology type of paper. Cognitive bias is all 104 of them. If you click on that link, it will take you to the original paper. Are inherent to humans and affect how we make decisions in the AI we build. And cognitive bias codex too much information and not enough meaning, need to act fast, what should we remember, and so on. So, for example, we discard specifics to form generalities. Well, that's what machine learning is all about. We discard specifics to form generalities. We reduce events and lists to their key elements. What should we remember? And we notice things already primed in memory or repeated often, right? Keep repeating it often and people will believe you. That's what they say, right? Too much information. We notice when something has changed. Anyway, there is all these biases, cognitive bias, are inherent to humans and affect how we make decisions and the AI we build. So we have 104 types of biases, and they affect the kinds of designs that we make. Here is something we encounter every day when we make a Google search, right? And when you type into Google artificial intelligence, it goes about it is the results it provides is based on your search. Not this top 6 Google image search results for AI debiased for the author's search history. So these are things are all taken out here, debiased. And it is kind of the result it is providing you. Risks of artificial intelligence, the first thing it's showing. Somebody who was searching on this topic of what is the bias of AI, what is the definition of AI, cut through the artificial intelligence, whatever, artificial intelligence something, how artificial intelligence is changing, understanding artificial intelligence, how to make artificial intelligence. Is artificial intelligence real or is, right? So these are all been blacked out here. It was all blacked out. They were asking for only images, and it is biased by search history. It is biased by search history is something we might all not be familiar with. Algorithmic systems have real world consequences. So in this case, uh, bias as in a model not representing the input data or ground data accurately is a machine learning problem. So these are all some examples of criminal sentencing. So this was an example of how this person was listed as low risk and this person was listed as high risk based on maybe racial characteristics, two drug possession arrests. And this was YouTube fact check algorithm incorrectly tags live broadcast, Notre Dame fire, and 9/11 attacks. So this is a, fact check algorithm. It is showing these images of the Notre Dame fire as well as the 9/11 attack on this side. So it is kind of showing them together. It's an automatic algorithm that is showing that. And here is something else, LinkedIn Com feed update. So it gives us immense pleasure. So this was about a school in India, and there was a camera system that was using AI, and there again, it was showing some bias here in terms of what it was focusing on. Biases in a model not representing the input data or ground truth accurately enough is a machine learning problem. And bias as in a model reflecting undue prejudice in its predictions is not simply a machine learning problem. Okay. Okay, sources of bias. Data is a big source of bias in machine learning, right? So of course, you feed whatever data and you're getting models based on that. Bias can see from other sources too, all the way from how AI researchers read humans, frame the problem, to how they train the model, to how the system gets deployed, right? So bias can seep in from other sources as well, other than data. So how you frame the problem, what are you saying is the task at hand? And this was a point about, I guess, made about Google. Women comprise only 10% of AI research staff at Google, and only 2.5% of Google's workforce is Black. This lack of representation is what leads to biased data sets and ultimately algorithms that are much more likely to perpetuate systemic bias. So the lack of representation among researchers, those who are developing the software, might itself have a role in what kind of bias has been built into this program. Okay, here is some interesting work that was done at MIT. This is a paper I got last year. And, I think the main author was this student, Harini Suresh, a PhD student there, who came up with 5 potential sources of harm in an AI system. So look at this. We have training data being generated here through this process. And then the training data is being used here to build the model and to provide post-process, integrate real-world implications. So whatever model outputs has a real-world implications. When it is saying something, give the loan or not give the loan, has a real-world implication. So there are 5 potential sources of harm identified: historical bias, data representation, and then there is a representation bias, right? And then there is representation. So what is historical? We'll see each of these in the next few slides. Historical bias, that is in terms of the data generation process. Maybe your data set was historically, it was biased. There's only so many people of a certain category. Population selection. So did you randomly select, or did you go about very biased type of select? What was the sampling process from it? And you have some population, and then measurement bias. What kind of measurements did you take from that data? Is there some kind of bias that can come into play? And that is the data set you have. The data set you generated has historical bias, representation bias, measurement bias, and that's what the data you have. Now we are doing pre-processing, training, testing, splitting, validation, and all this, and that gives you, the training data here, and there is the evaluation data here. And so the whole thing is selection, measurement, pre-processing, and then you have some benchmarks. Maybe you have benchmarks also. This evaluation data is benchmarks, that is, we're comparing against benchmarks. Let's see, the training data you generate like this, use optimization and construct a model definition. What kind of model are you using? Is it a neural network, or if it's a neural network, how many layers and all that type of thing? And you have evaluation bias. What kind of bias that could go in evaluating this model? Is it representative of the entire population? And then we run the model, and that will give the model output. We run the model on any new inputs, and then post-process integrate into system, and there are real-world implications. Okay. So historical bias arises when there is a misalignment between the world as it is and the values or objectives to be encoded and propagated in a model. All right. So, this is the first point. Historical bias is this part we're talking about. Historical bias arises when there is a misalignment between the world as it is and the values or objectives to be encoded and propagated in the model. So a normative concern with the state of the world and exists even given perfect sampling and feature selection. So between the world as it is, that this is the true population of the world, and we have some set of samples which are not really representative of the world. It's a historical bias with the state of the world, and there is the normative concern with the state of the world. It exists even if the sampling is perfect and feature selection is good. Even then, the way it has been encoded and so on might be an issue. Representation bias arises while defining and sampling a development population. It occurs when the development of population underrepresents and subsequently causes worse performance for some part of the final population. So this is about the sampling part of it, which is fairly obvious. Measurement bias arises when choosing and measuring the particular features. This is what kind of features did you use? Features considered to be relevant to the outcome are chosen, but those can be incomplete or contain group or independent noise. In many cases, the choice of a single label to create a classification task may be an oversimplification that more accurately measures the true outcome of interest for certain groups. Evaluation bias occurs during model iteration and evaluation when the testing or external benchmark population do not equally represent various parts of the final population. This is the evaluation, that final part. Evaluation can arise from the use of a performance metrics that are not granular or comprehensive enough. That's, you are not using a proper metric. Accuracy, F measure, and so on, whatever you're using, is there some kind of a bias in the measurement itself you're using? Aggregation bias arises when flawed assumptions about the population affect model definition. Many applications, the population of interest is heterogeneous, and a single model is unlikely to suit all subgroups. Okay, so that's what I have on this topic, and happy to take any questions you might have on any of this, because this is a very broad topic, as you saw, right? And okay, are there any questions on this broad topic of ethics in AI? Okay. Meher, are there any chat? You know, somehow I can't see the chat questions. All right. Shall we move on then?
Yes, Professor, there's no questions in the chat
Okay.
section.
All right, then you can do the quiz and all that. Okay. I'm going to turn off the recording.